Today we're going to take a look at graphing logarithmic functions, and we're mainly going to use transformations. You can use a graphing calculator to get tables, or just put in various inputs for x and get your outputs for y if you want to do it with a table. So first let's take a look at the characteristics of the parent function for y equals log base ax. I put an a there because really logs have many different parent functions. It mostly depends on the base, but your variable is x. So for all log functions, your domain is going to be x is greater than 0. Notice it's not equal to 0, because that is because you cannot take log of 0. So all parent functions will be x is greater than 0. If you're graphing something with a horizontal transformation, you're going to have to solve the inside of that parentheses. So if you have x plus something or x minus something, you're going to take whatever is in that parentheses, make it greater than 0, and solve for x. The range is all real numbers. Now, it doesn't matter what transformation you do, your range is still going to be all real numbers. Your parent function will have these common points. 1 over whatever the base is, -1, 1, 0, and then whatever the base is, 1, and then whatever the base is squared, comma 2. These common points depend on what the base is. So we have an example here of y equals log base 2x. If you'll notice, the first point that's pretty easy to see is 1/2 for x and -1 for y. So that's the point 1 over a -1. And then we have 1, 0. And then we have a squared. Since a is 2, a squared would be 4, comma 2. So that's that point right there. For transform log functions, you can transform these common points. So the 1 over a, if you have a horizontal transformation, you would add or subtract to that. For the 1, 0, you'd add or subtract to that. For the a, you'd add or subtract. For the a squared, you'd add or subtract. If it's a vertical transformation, you would add or subtract to the y value. Remember, horizontal does not affect vertical. So if you have a horizontal transformation, all the y values stay the same. The only thing that changes are the x values. Another characteristic of the parent function is that the asymptote is at x equals 0. Now, if you're graphing something with a horizontal transformation, x plus a number or x minus a number, you can find the vertical asymptote by making whatever is inside those parentheses equal to 0 and then solving for x. So let's do a quick review of transformations. If I have a logarithmic function in the form y equals a log x minus c plus d, if a is more than 1, you have a vertical stretch. So if a was 2, you would stretch your graph by a factor of 2. If a is between 0 and 1, you have a vertical compression. So if a was a half, you'd compress it by a factor of a half. Now when I say a, I'm talking about whichever number is in this position right here. I'm not talking about the base in this case. If a is negative, you'd have a vertical flip. I don't think you're going to see a vertical flip in this unit, but just in case, that's what it does. C gives you your horizontal shift. C is located inside the parentheses. It's the one adding or subtracting with the x. Now, if C is negative, you're going to have a horizontal shift to the right. And if C is positive, if you have x plus C, you're going to shift to the left. D is on the outside and it's adding or subtracting. That is a vertical shift. If it's plus D, it's going up. If it's minus D, it's going down. Now, here's the thing about C. As you move left and right, your asymptote is also going to change. So your vertical asymptote, which is usually x equals 0, is going to shift left and right based on if you have a horizontal transformation or not. Shifting that vertical asymptote will also shift your domain. So this will basically help you graph all graphs because you will just move that same shape around all different places. And that's basically it.